I don't know, 50, 60 operators in this library. Not gonna tell everything about that. However, we're gonna try and read a couple of marble diagrams. That's essential to understand the documentation for RxJS. It's a kind of a graphical way to show you how the sequences, the observable sequences work over time. Then, hopefully, if you have time, we're gonna jump into higher order observables. And we're gonna see an example, a practical way. Okay, so if any of you can understand this sentence and all the implications, then this lecture is probably gonna be boring for you. But if you don't, hopefully in 40 minutes you will. Okay, so why RxJS? To me, it was actually not a very romantic reason. We decided in principle, we decided to rebuild an application in Angular 2. And Angular 2 just happens to use RxJS. So I was kind of forced to learn RxJS and forced to love it. And now I do. It's kind of awesome, but not at the start. So if you remember AngularJS, it originally used promises. For example, you had like HTTP requests, and then it created the promise. You just waited for it. That's it. Angular 2, if you create an HTTP request, you get observable. So you just need to handle that. And also, how many of you have been to the Redux lecture in the morning? Okay. In Angular 2, Redux uses RxJS extensively. So we store the whole state of the app is kind of a sequence of states. So every time there's an action, there's a new state created, and it's pushed into a sequence. We just observe it. Or we can observe part of these states, right? So to me, yeah, that was the reason. Okay, so RxJS, yeah, blah, blah, blah. That's what Tomek said. Okay, we have like two main things we need to handle asynchronously in JS or in frontend. That's user interaction, HTTP requests. However, for example, I didn't listen to the previous lecture because I was so stressed about this one, but I think it was about service workers, right? Web workers. Yeah, web workers are also asynchronous. So you can, I guess, so you can handle that as well in a synchronous way. So yeah, let's start with a code. Can you hear me? No. Shit. No, it's okay. Can you hear me now? All right. So this is perhaps you know this code. You've seen it or used it. But let's check it out. Okay, so which one was it? This one. Do you see that? Yeah. Okay. Okay, let's run this just to make sure it works. Nothing changed in Chrome browser. Yeah, it works. We click and it console logs stuff. Okay, so that's even handling with callbacks. So Tomek already mentioned a couple of bad things about this. And so the add event listener method, it doesn't really return anything. So that means you need to handle everything that happens in reaction to event. You need to handle this inside the callback function, which means sequencing is hard, and doing things in parallel is even harder. So there's a cool presentation by Dominic De Nicola, who actually explains what was wrong with callbacks and why the JS community introduced promises. So yeah, sequencing, you get callback hell. Handling parallel things, that's even weirder. So you need to handle everything in reaction to event. You need to handle this inside the callback. So then you need to create some kind of a state which is scoped to be read somewhere else. So yeah, that's one of the dirty ways of event callbacks. So promises, we introduced that as a community to solve a couple of these problems. And probably, like most of you, pretty much understand what's happening here. That's not very complicated. And the result should be similar to the event handler we did previously. So let's check it out. Yeah, that's a promise. Let's run it. And yeah, I clicked. That's awesome. But then I click again and not really, nothing's happening. Why? Because promises kind of represent like a single value. They promise that something's it's gonna be resolved into something or rejected. And that's it, the promise is destroyed. Well, not destroyed, but it's not gonna react to the next resolves, right? So it actually, Tomek mentioned it, that if I'm gonna try to resolve or reject once more, it's gonna be ignored. So yeah, that's a problem, but then promises introduced some cool ways to handle parallel code. So I'm not gonna run this code because you probably will believe me that works. And Tomek already did that. So that's parallel, and that's the sequence. Actually, I don't think he mentioned that. You can, I'm gonna run this one. So check it out. Yeah. So what's gonna happen here is that we're gonna wait for a click and console log the result, but then we're gonna create a new promise. And creating this new promise, we're gonna use the result of the previous promise. So what I'm going to resolve with is gonna be client X. Sorry, client X. So the X-axis place I clicked. And then I'm gonna create a promise which will resolve after like 10 times the X. Okay, let's run it. So okay, I click. So about 2 seconds, and yeah, timeout hit. Let's make it again. 3 seconds. That's sequencing, and it's done way easier than with callbacks. No callback hell. Everything is kind of linear. And yeah, every then method will return a promise, so we can chain this into however long we want. Okay, so let's dive into observables. This is, you know what? Let's just run this code and see what happens. Yes. So from event. This is a teaser, don't look at it. This is a convenience method to create observables, and it takes like the element and event we're gonna look at, and then we subscribe to it. It kind of like the structure kind of looks like promises. It's pretty similar, but it's not the same. I'm gonna check out the differences in a while. Yeah, so let's run this code. And I click, and I click, and I click. Yeah, it's a sequence of clicks. Marvelous. Yeah, so from event is kind of a convenience method to create observables. This is the maybe more original method. to do this. So this is this is a sugar for observable constructor, and if you want to create an observable, you pass so-called, I think it's called, this function is called observable execution, right? And observable execution gets an observer as an argument, and this observer accepts, like, it has like 3, let's say, methods or callbacks. The most important one being next. So each time we listen to click event, we next the observer, and when we subscribe to the observable, the first callback is going to be the function that will be executed once observer next happens. So it's kind of, this is the same thing, right? Next, this is going to be next, right? So I can actually even name it. Oh, Jesus, live coding. Whatever. You're gonna see it on the slide. Okay. So yeah, that's the creation part. Again. And yeah, let's check out one interesting thing about subscribing. So this is, you remember Tomek saying, citing actually Andrea Stolz about the difference between promises and observables, that promises are eager and observables are lazy, right? So promise is eager because even if you don't then a promise, it's gonna happen, it's gonna be created, right? Observable, not really. So check out what's gonna happen to this code, right? If I don't subscribe, I just console log, I'm created. Yeah, and run it. Right? Nothing. Wow, why? I subscribe to, and is that the thing? Yeah, let's run it. Yeah, I'm created, and now I work. I don't subscribe. I'm not created. Interestingly, I subscribed 2 times, and foo, whatever. I'm created 2 times. So that's weird, and it has some consequences. Check out this code. I'm gonna, like, interval is another convenience method to create an observable, and it's gonna be like a clock, okay? So every second it's gonna it's gonna push an element into the sequence, and this element is gonna be a number incrementing every second, right? This is another cool method. I'm gonna just take 5 elements of this sequence, and then the whole sequence is gonna complete. So if I end this this way, just subscribe once, subscribers. Okay, so it immediately started ticking. That's it. We just take 5 elements, all right? So now I'm gonna subscribe to it after 3 seconds. So maybe some of you already predict what's gonna happen? Anyone? I know some guys do. All right, let's check it out. Okay, so, that's a late subscribe, okay. So it kind of joined. it didn't actually join. This counter, it started observing another counter. So yeah, every subscriptions created a new sequence, and it started from 0. I think you get it. Okay, so every time you subscribe, we trigger a new observable execution. The new sequence is created. And these sequences are not shared by default. And that's called called observables. So the difference, and again, I'm gonna kind of cite the words of Andres Stals. This guy is like a core contributor to RxJS. Also, I think the creator of Cycle.js, right? And he kind of, in one of the tutorials, he said that the difference between cold and hot observables is like the difference between like a regular YouTube video and a streaming video, the streaming of like a live event or something like that. So if I start watching a video and then my friend starts after a minute, at the same time we see different things, right? He sees something that happened a minute ago in my video. But if we both start watching like a soccer game, streaming, we're gonna see the same thing at the same time. So by default, observables are called. So every time you subscribe, we just get the sequence from the very beginning. But there are ways to make it hot. And I'm gonna show it to you by the end of this presentation. Alright. Okay, so this is observer. This is actually copied from the documentation. As like observer, this is a very naive implementation, but it kind of like gets the idea. You have next, which is the next element in the sequence, like the function that is gonna be executed once the next element in the sequence appears. The error, which is like a little bit like promise reject, and the complete. So complete doesn't give you any values or anything. It just notices that the observable sequence is no more. Like potentially, for example, in this example with clicks, potentially the sequence is infinite until I complete it in a way. Okay, so this is a full subscription example. I can pass 3 functions. And these functions are going to be called on next, on error, and complete. Okay, so since we're dealing with collections, collections of data, even though they're asynchronous, we can use some sweet methods we used to know from synchronous arrays. Like map, filter, reduce. Scan is a new thing. I'm going to show you the difference between reduce and scan. Concat, etc. So yeah, let's check out this example. Yeah, you see it okay? Okay, first I'm gonna remove the filter and just... So this is an interval, so it's gonna give me 5 numbers, but I'm gonna cast it into a string of number plus CA. And that's mapping, that's like very simple thing, right? So let's check it out just to make sure. Yeah, 0 to 4 EAs, okay. Let's filter that. So now what I'm gonna look at or accept, or put it another way, the filter method will return another observable sequence, but only of numbers which are not divisible by 2, right? So let's check this out. Yay, okay. That's filter. Now reduce. That might be this one actually might be a little surprising for you. So what happened? Maybe I'm gonna throw the yays away, all right? So what happened here after reduce was called? We got just one element. That's because reduce actually waits for the whole sequence to complete, and then it reduces all the elements. But maybe you want to get, I'm gonna remove the filter, all right? Maybe you want to get a sequence of the summaries of every time another element in the sequence appears. That's what scan gonna do. So scan gonna accept all the elements, and it's not gonna wait for the sequence to complete. It's gonna do the reduction operation every time it gets an element. So this time, yeah, it's okay. It summarized the strings, so remove that, and we get the sum of all the previous elements. So that's reduce and scan. Concat, on the other hand, is a little bit different. So that's a good occasion to introduce marble diagrams. This is an example for a concat method. So the top two axes represent like two observable sequences, and you can kind of think of it as timelines also. So the first sequence is coming. It's like it has like 3 elements, and then it completes. And the second sequence has just 2 elements and completes pretty fast. You can see that these 2 elements have been emitted even before the first sequence emitted the second element. But what concat did, that's like the third axis is the result of the concat method. Sorry. So this result is a new observable sequence, and this sequence you can see that it took the first. At first, it took all the elements from the first sequence. It waited for it to complete, and then it also emitted the other 2 elements from the second sequence. So this is the resulting sequence. And let's check it out in the code. So I have 2 intervals. I'm gonna take 5 for each one of them. This one's gonna be mapped to a string, so we can see the difference. And then we concat 2 of them, subscribe, and let's see what happens. So the first sequence going on, and then the second one. So concat waited for the first one to complete, and then it allowed the elements from the second one to enter. Okay. Yeah, so that's concat syntax. Here's another marble diagram, and this one is a little bit more complicated, and it also introduces something called higher order observables. So, like, the top axis is an observable sequence of observable sequences. So that's symbolized by this kind of branching out. This one and this one are so-called inner observables. This one is higher order observable. Higher order because it emits lower order or inner observables. So, and say this one has some numbers and this one has some strings maybe, right? And then we have a method to flatten this. Flattening means that the first, like the sequence of observables is being like transformed into a sequence of elements which are emitted by the inner observables. So I'm gonna show you the code in a second. You're probably gonna understand it easily. But notice that how switch works, because there are a couple of ways we can flatten a higher order observable. And this one, what it does, notice that it accepted the first element from the inner observable, the second one too, but the third one, no, it's gone. It's like, where is it? So it's gone because the main higher order observable emitted another inner observable. It started here and switched to another one. It unsubscribed from this one, so it doesn't. So it kind of ignored this element from the first observable. It switched to another one, and then it lets all the elements from the other inner observable in, right? And the resulting sequence ends here, because both inner observable and the higher order observable completed. Okay, so let's check out the code for switch. So we have a clock and a click, and the clock is like every half second we take just 5 elements of that, and click, you know, watching for events. So what you're gonna do is create a higher order observable, which will map every click into a clock. And then we're gonna switch from the click, from the elements emitted by the click sequence to the elements emitted by the clock sequence. And then we're going to subscribe to it and try to console log the result. Okay, so let's run this. So I click, and the clock starts. And I click again, and it started again. So maybe someone knows what's going to happen if I click 2 times. Okay, what? Yeah, exactly. It's gonna switch to, it's kind of, okay, check it out. 1, 2, okay, I click. It starts from the beginning. It started from the beginning, but of the second clock. It stopped listening to the first one here, and it started listening to another one. That's switch for you. Okay, so there are other ways to flatten a higher order observable. And switch is one of them. There's merge all and concat all. Let's take a look at this merge all diagram. So you can see that in contrary to switch operator, even though another inner observable started, it accepts the elements from the first one. So C and D are going into the final sequence. However, it's kind of mixed in time with the elements from the second inner sequence, right? Okay. So yeah, let's check out why the hell do we even want RxJS. You know, first I'm gonna show you how this app works. I did this just for, you know, for the purposes of a demo, but it's pretty cool, I guess. Right, wonderful UI, and this app is gonna, when I write something, and maybe something meaningful, and then maybe something here. So I can see the history of all my edits, one way or another. So how did I achieve that? Let's take a look at the code. So I created a couple of observables. So this code is like CycleJS style to create a from event observable. So I'm looking at my text area and I'm watching for any changes in the input. So I just need to map the target value. And what I do here is I publish replay. So remember when I was talking about cold versus hot observables, right? So publish without replay will turn this one into hot. Publish replay will turn this one into a hot observable, but it will also, every time someone subscribes to it, it will emit the whole sequence from the beginning of its life. Like, and its life starts with this connect operator or method. So at the beginning of this working application, I start to kind of recording everything that is being input into the text area. So I have another observable which observes just the event of dragging this one. And I have a scan observable which watches the length or the amount of changes in the input that the user did here. I do that because then I have like a historic text observable which will combine the latest elements of two sequences. The history range, so the sequence which tracks this thing, and the text count, so the thing that changes every time I change the text. So combine latest accepts another like two, it accepted two observable sequences and kind of a callback function, which will get the results emitted by this one, results emitted by this one, and we'll combine the latest results. And then we create another observable. So that means that this whole thing is higher order. I mean this thing. That's why I'm gonna have to switch. So this observable will skip the amount of elements I want to and just take one of them. So this is gonna be the exact place in history of edits that I want to show. And then because this is inner observable, I have to switch into the result into this the elements of this sequence. Sorry. Yeah, so that's it. The only last observable sequence is because how the CycleJS is constructed. It actually treats the whole DOM as a sequence of like states, maybe. So every time I change something, I kind of rebuild the DOM. I don't know if it's like smart, like in ReactJS, probably is. So it's hot swapping the things that changed, and the things that changed was this text area. Okay, yeah, that's it. Some useful resources I used to create this presentation. Right, I forgot. Watch out for the names of the methods in RxJS because it's migrating and it's not always obvious which article or which documentation is about which version. So some names I gave you, I tried to give you the names from RxJS 5, but in some tutorials you will get different names for for the methods I used. So I think switch used to be called something else, or publish used to be called share and stuff. Okay, so reactive X docs is partially about RxJS, but you can also dive into the other implementations in other languages. So this documentation is kind of language agnostic. And I really recommend Andrei Stolz and Ben Lesh tutorials and articles. They both are really active. They have their blogs on Medium and quite nice tutorials on Egghead. They are both, Andrei Stolz is like core contributor to RxJS, and Ben Lesh is, I think, the lead programmer for this project. So yeah, that's definitely the address you want to go to if you want to dive a little bit in. Yeah, thanks.